15 years ago, Scotland released just 11 beavers into Napdale Forest. It was a small experiment aimed at reviving a river on the brink of collapse, a river that hadn't seen beavers for nearly 400 years. At first, scientists expected modest changes, but as they began reviewing the water data, they saw something that no human model could explain. Streams were holding 60% more water, flood peaks were dropping by half, and the river seemed to defy everything hydrologists had learned. How could a handful of animals out-engineer decades of costly flood defenses? The answer challenged everything scientists thought they knew about water management, and why nature sometimes outperforms the best human plans. Centuries ago, Scotland's rivers flowed to a different rhythm. Water slipped through dense forests, slowed by beaver dams that turned streams into a mosaic of pools, ponds, and marshes. Beavers were once part of everyday life. They were hunted relentlessly for pelts, meat, and castoreum, a substance prized in perfumeries and pharmacies across Europe. By the late 1500s, the last Scottish beaver had vanished. Not just a species was lost, but a quiet force that shaped the land for thousands of years. 4 centuries passed in silence. Rivers grew impatient, straight and narrow, tearing at their banks. Wetlands shrank, drying the land and leaving the soil bare. Floods became violent, while dry spells cracked the earth. The lush forests of Napdale collapsed into scattered fragments. Birds, insects, wildflowers all disappeared from the emptied landscape. Generations grew up never knowing the world the beavers had built. Rivers were seen as fixed, harsh, and unchangeable. By the late 20th centuries, a few determined scientists and historians began questioning this collective amnesia. They dug through ancient records, tracing evidence of vanished wetlands and forgotten abundance. Could the loss of beavers have triggered a chain reaction, stripping the land of resilience? Could this damage, centuries in the making, be reversed? In May 2009, 11 beavers from Norway arrived in Napdale Forest. They spent weeks in quarantine, monitored for disease and stress, before being released into 3 separate lochs connected by winding streams. The Scottish Wildlife Trust and the Royal Zoological Society of Scotland led the project, with NatureScot conducting independent monitoring. Every step was measured, every outcome documented. Hydrologists from the University of Stirling installed pressure sensors and flow gauges. Baseline surveys captured water chemistry, dragonflies, vegetation plots, fish, and invertebrates. The lead scientist, clipboard in hand, oversaw a grid of monitoring points, ensuring nothing went unnoticed. Local rangers walked transects daily, noting every tree and patch of undergrowth. Camera traps blinked at dusk, capturing the first tentative steps of the beavers. The first morning, a ranger found the first dam wedged between alder roots. Mud and sticks packed so tightly that even the swiftest current slowed to a crawl. Beavers worked silently, gnawing saplings, dragging branches, and weaving stems with a patience no machine could match. Each night, the dam stretched a little further, transforming narrow channels into shimmering pools. By the second year, the changes became impossible to ignore. Single streams now meandered through a patchwork of ponds, marshy flats, and braided rivulets. The ranger counted new dams, 3, 5, and then more than a dozen. Each structure was unique. Some were small heaps of chewed branches, others rose knee-high, water spilling gently over their crests. Behind each dam, water fanned out, soaking moss and leaf litter, flooding hollows empty for decades. Trees leaned at odd angles, gnawed and scarred. Willows and birches sprouted where only bracken had grown. Frogs and dragonflies returned. Deer tracks appeared in mud that had long been dust. Beavers patched leaks, rebuilt after storms, and adapted as water found new paths. Some dams failed, only to be rebuilt stronger a week later. Over time, the valley blurred. One straight stream became a web of channels and pools, each reflecting the sky in different shades. By the 5th year, hydrologists' numbers refused to fit their models. More than 100 beaver dams, some over 30 meters wide, now stepped down the Napdale valleys. Each acted as a natural barricade, slowing the river, spreading water across the floodplain. Pressure sensors showed water retention had risen by 60%. Downstream, villages noticed a remarkable change. Flood peaks during heavy rains dropped 30 to 60%. Engineers were stunned. Computers couldn't reproduce what the beavers had done. Their dams didn't just hold water in one spot, they created a chain reaction of small reservoirs, catching, storing, and gradually releasing water. Rainwater slowed behind the first dam, spilled into the next and the next, losing energy at every step. The river's power was absorbed not by concrete or steel, but by a living, adaptive system. Water seeped sideways into the soil, raising groundwater tables and feeding long dry channels. Sediment settled, water downstream cleared, and the valley floor became broad, spongy wetlands. Pools lingered even during droughts, keeping base flows steady. Concerns about salmon proved unfounded. Most dams were on small tributaries, not main channels. Juvenile salmon found refuge in the slow pools, growing larger and stronger before heading downstream. Heavy rains washed out or opened dams, allowing adult salmon to migrate. Populations thrived in places they hadn't been seen for decades. Engineers learned a humbling lesson. Beavers had built a self-maintaining, responsive system that outperformed models, absorbed shocks, and delivered benefits that concrete never could. Nature's design, measured in real time. In November 2016, the Scottish government declared that beavers could stay. The trial had produced undeniable results, but the decision also meant balancing ecological restoration with the realities of farming and land management. Compensation schemes helped some farmers, while others faced conflicts and frustration. Full legal protection arrived in 2019, but in the meantime, management required licenses and careful monitoring. By 2020, the Napdale story had crossed borders. In Devon, the river otter beaver trial mirrored Napdale's path. Careful monitoring, dialogue with farmers, and willingness to follow the evidence led to similar results. Beaver dams slowed floods, improved water quality, and brought back species lost decades ago. The population stabilized, habitats flourished, and government verdicts allowed beavers to remain. Lessons from Napdale shaped new projects across the UK. Yet limitations remain. Beaver engineering works best on small to medium streams. Large rivers, urban channels, and intensively farmed floodplains pose challenges. Adaptive management, ongoing monitoring, flow devices, fencing, or even relocating animals may be required. The lesson is clear. Natural solutions are powerful, but only when paired with patient science, communication, and a willingness to learn from the land. As climate risks grow, the question is not whether beavers help, but where, how. With what support from 11 beavers in 2009 to over 100 dams by 2014, Napdale's rivers were transformed. Water retention rose 60%, flood peaks dropped 60%, and engineers' models were surpassed. The trial proved that beavers can deliver real benefits for water management, biodiversity, and climate resilience. Today, beaver reintroduction is expanding across Britain. Napdale shows that when given the chance, natural processes can rival and often outperform engineered solutions. After centuries of absence, Scotland's beavers have reshaped more than rivers. They have reshaped how we understand and manage the land itself.